Hello students, welcome you all. In my previous lecture of this pericyclic reaction, I told you how to draw the pi molecular orbital diagram for ethene and butadiene. I also told you the rules for drawing these molecular orbital diagrams. So in this lecture, I will tell you that how we can draw the pi molecular orbital diagram for hexatriene and its octatetraene. So let me draw the pi molecular orbital diagram for the hexatriene. So this is the hexatriene system. It's 6 carbon system or even carbon system, and we can also show the p orbitals over here. 1 p orbital, 2, 3, 4, 5. So 5 p orbitals. 5 p orbitals they will combine to give the 6 p orbitals. 1, 2, 3, 4, 5, 6 p orbitals they will combine to give 6 molecular orbitals. So we can also write this hexatriene in this way also. You may write. Okay. So number of p orbitals in hexatriene, number of p orbitals combined, they will combine. This is equal to 6, and number of molecular orbitals formed, this will also be equal to 6. Okay. So 6 molecular orbitals are present. So we can show the 6 molecular orbitals. So 1, suppose this is first one, I write it by psi1, giving name psi1, and this is suppose second, psi2, third, psi3, psi4, psi5, and psi6. 6 p orbital I should draw. 1, 2, 3, 4, 5, 6. In the same way here also. Okay, so these are the 6 molecular orbitals of the butadiene. So I should first write the node, number of nodes, as I told you in my previous lecture, rules for drawing this pi molecular orbital diagram. So for psi1, for first one, number of nodes, that is equal to 0. Second one means what I told you, for psi nth molecular orbital, number of node will be decreased by 1, that is psi n minus 1. So for psi nth, number of nodes, that would be psi nth minus 1 and minus 1. So for psi 2, number of node will be 1. For psi 3 it is 2. For this it is 3. For this it is 4. And for this it is 5. Okay. Now I should write the bonding interactions. Total number of bonding interactions in psi 1. In psi 1 that would be equal to 5. This will be 4. This will be 3, 2, 1, 0. Anti-bonding interaction. So we should start with 0, 1, 2, 3, 4, 5. It ends with 5. So this ends with 5. This ends with, start with 5, ends with 0, start with 0 and with 5, like this. Now what should I do? I should give the signs. So total number of bonding interaction is here 5. And the first molecular orbital, if you are drawing any diagram for either for ethene system, butadiene system, or hexatriene, octatetraene, and so on, the first should have the sign all plus. It should have all plus, 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 plus. So if you will see here, number of node is 0. When the node come, when plus minus interaction, then node come. Here the node is 0. Bonding interaction, if you will see, 5 bonding interaction. 1, 2, 3, 4, 5 bonding interaction, you can see. Now side 2, number of node is 1. So this is odd molecular orbital. So odd molecular orbital, I told you the rule, and orbital should have the same sign, positive. For all odd, psi 1, psi 3, psi 5, and orbital should have the same sign. So I can write for all odd and orbital should having the same sign, plus plus. This should also have the plus plus. Okay. Even molecular orbital, that should have opposite sign, and orbital of even molecular orbital, psi 2, psi 4, psi 6, that should have the opposite sign. Okay, that should have the opposite sign. So if this is plus, then this should be minus, like this. In the same way, this is even molecular orbital, so and orbital should have the different sign. This is also even molecular orbital, the and orbital should have different sign, plus and minus, like this. So now we should give the other sign also. So if you will see here, then psi 2 contains only one node, and always what I told you, the distribution of nodes should be symmetric. The distribution of nodes should be symmetric, and one node that should be passed through the center. So that one node should pass through the center, and if this is plus, so this should be also plus, this will be plus. Because here one node is present, that's why you should give here the sign minus, this will also have the minus. Now if you will see the bonding interaction, how many bonding interaction? 4. So how can we see you? 1, this is 2, plus plus, same sign, then bonding interaction. If different sign, anti-bonding interaction, minus minus, minus minus. Okay, and I should give the name of this lower lobe also, sign of this lower lobe, like this. Okay, anti-bonding interaction is 1, so only anti-bonding interaction is in the middle. Now psi 3 number of node is 2. Okay. So if node is 2, no doubt that will not pass through the center. So from where it should pass? So this node should pass, how it should pass? So this node that will pass from one of the node from here and another node from here. And you will see the interaction here, the bonding interaction is 3, anti-bonding interaction is 2. So if this is plus, this will also be plus. If this is plus, because node is present over here, this will be minus, plus. If this is minus, then node is not present over here, that's why it is minus, this is plus. If this is minus, then since node is present over here, that's why it should be plus and it should be minus. So if you will see the bonding interactions, how many bonding interaction you can see? One of the bonding interaction 1, this is 2, this is your 3. 3 bonding interaction. And 2 anti-bonding interaction. So anti-bonding interaction, this is one of the anti-bonding interaction, and this is your another anti-bonding interaction. 2 anti-bonding interactions are present. Now psi 4, 3 nodes. Psi 4 is 3 node, odd number of node, no doubt one of the node that should pass through the center. Okay. Other node, one of the node over here, and another node over here. Okay, so you should write plus, minus, minus, plus, plus, minus, minus, So how many bonding interaction you can see? Two bonding interaction. This is one of the bonding interaction, and this is the another bonding interaction. Three anti-bonding interaction, plus minus, plus minus, plus minus. Three anti-bonding interaction. Psi 5, four nodes. If four nodes, it means that should not pass through the center. So only possibility one node over here, 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 here. Leave this center and these are the four nodes. Okay, so give the sign plus, minus, plus, plus, minus. Okay, clear? So if you will see the bonding interaction, how many bonding interactions? This is one of the bonding interaction. And anti-bonding interaction, four anti-bonding interaction, one plus minus, plus minus, plus minus, plus minus, four anti-bonding interaction you can see. So what about this psi 6? So psi 6 you can write easily, just give the opposite sign to all the lobes, plus minus, plus minus, plus minus, like this. First molecular orbital, give all sign positive. Last molecular orbital, give all sign positive, negative, alternate signs. And second molecular orbitals, half positive, half negative. In all molecular orbital diagram we will see like this. First one all positive, last one alternate, plus minus, plus minus, plus minus, and second one half positive, half negative, and rest of the thing you can see with the help of nodes, bonding interaction and anti-bonding interaction. So this is about these are the six molecular orbital diagram, six molecular orbitals of the hexatriene. Now what about the symmetries? So symmetry, if you will see, sigma symmetry, that is mirror plane symmetry, and C2 symmetry. So if you will see mirror plane, then mirror plane that should, if you will pass the mirror plane from here, if you pass the mirror plane from the center, then in front of plus, all plus are there, so that's why it is symmetric. It is symmetric with respect to the mirror plane. This one, if you will pass the mirror plane from the center, then in front of plus, plus is not coming, it means it is anti-symmetric. This will be symmetric, this will be anti-symmetric, this is symmetric, this is anti-symmetric, and so on. So write in alternate fashion. In the same way, if you will see the C2, then rotate it by 180 degree. So at plus, this minus will come. At this plus, this minus will come. So that's why you will not get the same molecular orbital diagram. So that's why it is anti-symmetric with respect to this. This is symmetric, this is anti-symmetric, this is symmetric, this is anti-symmetric, and so on, like this. You can write in an alternate way. Okay. So in my previous lecture, I have shown it with the help of model. You may see my previous lecture, and with the help of model, you will better understand how we can give the mirror plane symmetry and C2 symmetry. Okay. So this is about the construction of pi molecular orbital diagram for the hexatriene. So let's see the pi molecular orbital diagram for the octatetraene. Okay, so octatetraene. 1, 2, 3, 4, 5, 6, 7, 8 carbons. Okay, or you may draw it this 8 p orbitals, they will overlap to give the 8 pi molecular orbitals of octatetraene. So number of p orbitals combined is equal to 8. Number of molecular orbitals formed This is also equal to 8. Okay, so I should draw the 8 molecular orbitals for this octatetraene. Okay, so or otherwise you may draw in this way also octatetraene. Okay, so let me draw the molecular orbitals for this octatetraene from psi 1 to psi 8. Okay, so from psi 1 to psi 8, first, second, third one, fourth, fifth, sixth, seventh, and this is 8th. We can give the name psi 1, psi 2, psi 3, psi 4, 5, 6, 7, 8. Okay. Now 1, 2, 3, 4, 5, 6, 7, 8, like this you may draw. Okay, so I should give the sign. So for simplicity, so you should first write the number of nodes. If you write the number of nodes, then follow the same rule that I told you in my previous lecture. Psi 1 should have 0 node. This should have 1, 2, 3 nodes. Psi 4, 3. Psi 5, it will have 4 nodes. Psi 6, 5 nodes. Psi 7, 6 node. Psi 8, 7 node. Okay, 1 node that will decrease. Okay. Then bonding interaction, write the bonding interactions. So number of bonding interaction, if you will see, this will start with 7 here because 8 molecular orbitals are there. Start with 7 and decrease 1 by 1. So 6, this is 5, this is 4, this is 3, 2, 1, 0. Anti-bonding interaction, start with 0, 1, 2, 3, 4, 5, 6, 7. Okay, from 0 to 7, from 7 to 0, from 0 to 7, like this. Now what I told you, all odd molecular orbitals, that is psi 1, psi 3, psi 5 and psi 7. The end orbital should have the same sign, and first orbital should have the same sign. All the p orbitals in first one, that should have the same sign. Last one should have the opposite sign. So we can give the signs for the first one and the last one. So write down this plus, 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 plus. Okay. I am not writing the sign for the lower lobe. You may write the sign for the lower lobe. So it is plus, minus, plus, minus, plus, minus, plus, minus. If you will see here, number of node is 0. Bonding interaction, if you will see, 1 bonding interaction, 2, 3, 4, 5, 6, 7 bonding interactions. Plus, 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 plus. Same sign give you the bonding interaction. Opposite sign give you the anti-bonding interaction. Okay. Now, similarly, as odd molecular orbitals, for odd molecular orbital, what I told you, the end orbitals should have the opposites, same sign. End orbital should have the same sign. This is plus, this will also have the plus. In the same way, the end orbital for psi5 is the odd one, give the opposite sign. 7 is the odd, give the opposite sign. Okay. For even one, end orbital should have the different sign. Start with plus and then minus. Start for psi4, start with plus, last should have minus. Psi6 is even, start with plus and with minus, like this. Now I should give the other signs. So psi2 having the one node. So psi2 having the one node, so the first node, no doubt, that should pass through the center. What I told you, the nodes should be distributed symmetrically. If odd node is present, number of node is odd, then no doubt one of the node, first node that should pass through the center. Okay, so here the first node that should pass through the center. What I told you, for the all, if you are drawing any molecular orbital diagram, then second one, the second one, half should have the plus sign, another half should have the minus sign. So this 4p orbital, that should have the plus sign, plus, plus, plus. And rest of the 4 that should have the minus sign, that is minus, minus. Okay, so one node, number of bonding interaction, if you will count, no doubt anti-bonding interaction, this is only plus minus, this is one anti-bonding interaction, but number of bonding interaction you will see, this is 6. So 1, 2, plus plus 3, minus minus 4, minus minus 5, minus minus 6. Now for third one, number of this interaction, the number of node is 2 and bonding interaction 5, anti-bonding interaction is 2. So from where that should pass? So like this, if you will see, then we can write this should pass through here, 2 nodes. So 2 nodes are present, 2 nodes, first node, second node, like this. Okay. Okay, so this is our first node, this is first node, and this is our second node, like this. Now if you will see here, if you will see, then this is plus and this is plus, this is minus, this is our minus, 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 plus, like this. Okay, 2 nodes. So number of bonding interaction, if you will see, 1 bonding interaction, 2, 3, 4 bonding interaction. Anti-bonding interaction plus minus 1, plus minus 1. 2 anti-bonding interactions are there. Now for psi4, number of node is 3. So one node, first node, no doubt that should pass through the center. This is the first node. Rest of the 2 node, another node, you should give here from here you will give the first another node and next node, that will be like this. So if you will see here, then I should give the sign now, plus, minus, minus, plus, minus, so plus and minus. Number of bonding interaction, count the bonding interaction. This is 1, this is 2, this is 3, this is 4. Anti-bonding interaction, 1, 2, 3. 3 anti-bonding interaction. Psi5, 4 nodes, and 4 nodes that should pass through the, from where it should pass? It should pass through the, no doubt, not through the middle, only this is even, so it should, where you will write, so one of the node that you may write 1, 2, and this is 3, and this is 4 node. Okay, so how you can give the sign? If you want to give the sign, then this is our minus, this will be also minus, plus, plus, minus, minus, plus. So bonding interaction, if you will see bonding interaction, then bonding interaction you can see 1 bonding interaction, 2 bonding interaction, 3, anti-bonding 4, 1, 2, 3, 4 anti-bonding interaction. Psi 5, if you will see psi 5, then one of the node that should pass through the center, and another 4 nodes that should pass. So 5 nodes are present. This is 1. Then I should write like this. So this is plus, okay, this is plus, minus, minus, plus, okay, and this is our minus, this is plus, like this, okay. So how many bonding interaction you may see? This bonding interaction is, this is 1 bonding interaction, and this is your another bonding interaction. Rest 5 anti-bonding interaction, 1, 2, this is our 3, this is our 4, and this is our 5. Now psi 7, if you will see psi 7, then number of nodes is 6, and that should pass through the, no node should be passed to the center, so we can write easily 1, 2, 3. So if you will give the sign minus, plus, minus, minus, plus, minus, like this. So if you will see bonding interaction 1, anti-bonding 3, 6, and like this. Here node you can see already I have drawn here 1, 2, 3, 4, one of the node that will pass to the center, and like this. So this is about the signs. Now if you will see the symmetry, sigma, mirror plane, and C2. So mirror plane symmetry, that will start with here. I can start, that is, this is no doubt if you will pass the mirror from here, from the middle, and this is half positive, half this. So in front of positive you will find the positive. So first you should write symmetric, and after that again you can draw the mirror plane over here. So anti-symmetric, symmetric, anti-symmetric, symmetric, anti-symmetric, symmetric, anti-symmetric. Okay. Draw the mirror plane and see in front of minus whether minus is coming or not. In front of minus, if plus is coming, it means it is anti-symmetric. So you may draw all the mirror plane from the middle and you can check. So for that you may see my previous lecture where I have shown it with the help of model. In the same way, whether it is symmetric with respect to C2. So for this, what should you draw? Axis and rotate it by 180 degree. So if you rotate, then in place of plus this minus will come, and in place of this plus this minus will come. That's why it is anti-symmetric with respect to C2. In the same way, here this is symmetric with respect to C2, because if you will rotate it by 180 degree, if you will rotate it by 180 degree, in place of plus this plus will come, and in place of minus this minus will come. That's why this is symmetric with respect to C2, and so on. In this way you can check anti-symmetric. So for simplicity, just first give A, and then you can write A as A as A as A as, like this. Okay, so this is about the molecular orbital diagram for the octatetraene. Now if you will see what is the HOMO here. So suppose I write psi 1, this is psi 2, psi 3, psi 4, psi 5, psi 6, psi 7, psi 8, and if you want to fill the number of pi electron, then total number of pi electron is 8 over here. So this is 2, 2, 2, 8 electrons. Now HOMO in this case, if you will see, that is highest occupied molecular orbital. And highest occupied molecular orbital, this is the HOMO here. This is the highest occupied molecular orbital, psi 4. So psi 4 is the HOMO for this octatetraene. And what should be the LUMO? That is lowest occupied molecular orbital. So this is not filled one. This psi 5 is the unoccupied one. Psi 5 is the unoccupied one. So lowest unoccupied molecular orbital is psi 5. So psi 5 is the unoccupied molecular orbital. So if you will see the sign for this molecular orbital HOMO, then what is the sign for HOMO? The sign for HOMO is plus plus minus minus plus plus minus minus plus plus, like this. If you will sign, like this. And if you see the sign for psi 5, that is LUMO, then it is plus, start with plus and then minus minus plus plus minus minus, and then 1 2 3 4 5 6 7 and this plus. In this way you can see. Okay, this is like this, plus plus minus minus plus plus minus minus. In the same way we can see the sign of HOMO for the other system also. So HOMO for, if you want to write the HOMO for butadiene, if you want to write the HOMO for butadiene, then HOMO for butadiene, that is, which is psi 3 is the, psi 2 is the HOMO for butadiene. This is HOMO. And psi 3 is the LUMO for butadiene. So if you want to write the sign for HOMO for butadiene, that how you can write? You can write in this way, following the same rule. So it starts with plus plus minus minus. And what will the LUMO for butadiene? You can say, following the same rule, it should start with plus and minus minus and then plus. For hexatriene, if you want to write for hexatriene, how you will write for hexatriene? So for hexatriene, psi 3 is the HOMO and psi 4, that would be the LUMO. So if you want to write the sign, you can write the sign for the HOMO for hexatriene. So plus plus minus minus plus plus. Okay, plus plus minus minus plus plus. LUMO, start with this plus and minus minus plus plus minus. So this is for LUMO for butadiene. So no doubt psi 3 is the odd molecular orbital. That's why odd molecular orbital and orbital is having the same sign. Psi 4 is the end orbital has this opposite signs. Now this is the pi molecular orbital diagram of octatetraene, and this can also be understood in a different way. One of the way to understand is this. I have drawn in this way. Or otherwise, this octatetraene, it may be considered as the combination of two butadiene systems. So this is one butadiene system and this is our another butadiene system. So two butadiene systems combine to give the octatetraene. Okay, or they may overlap to give the octatetraene. So how can we understand when it is similar to the butadiene? Like butadiene can be considered as a combination of two ethene system. In the same way, this can be considered as a combination of two butadiene system. So let's see how we can combine two butadiene systems, molecular orbitals of two butadiene system, to get this molecular orbital. Okay, so suppose if we have butadiene molecular orbitals, this is pi 1 and this is pi 2, pi 3, and this is the pi 4. So let's give the sign here. This is plus, 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 plus. Okay, all plus. Here half plus, half minus, plus, plus, minus, minus. And here if you will see, then two nodes are present over here. So this is plus, minus, minus, plus. And this is plus, minus, plus, minus. All opposite signs. In the same way here also I should draw okay. So all plus, half plus, half minus, and plus, minus, minus, plus, plus, minus, plus, minus. Okay. Now, so this is again, this is pi 1, pi 2, pi 3, and pi 4. So this pi 1, so this will overlap. Pi 1 can overlap in a two-way, constructive and destructive. So when constructive overlap, the middle orbital should have the same sign, and for destructive overlap, middle orbital should have the opposite sign. So plus, 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 all plus you can see here. When destructive overlap, plus, 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 plus means all plus here, and then minus, 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 minus in the opposite way. Okay, so in the opposite way, that is means this is pi 1 minus pi 1. This is pi 1 plus pi 1, or this is pi 1 minus pi 1, like this. In the same way, this is pi 2 plus pi 2. So what we will get? Plus, plus, minus, minus, and minus, minus, plus, plus. So that the middle orbital is having the same sign. Middle orbital is having the same sign. This is pi 2 minus pi 2. So what we will get? Plus, plus, minus, minus, plus, plus, minus, minus, like this. And here if you see, the middle orbital is having the different sign. In the same way, this you will get this molecular orbital pi 3 plus pi 3, and this is pi 3 minus pi 3. Okay, so plus, minus, minus, plus, again plus, minus, minus, plus. So this is for psi 5, psi 6, plus, minus, minus, plus, plus, minus, minus, plus, and then minus, plus, plus, minus. Okay, so you have to add this pi 3 either in a constructive way or in a destructive way to get this orbital. In the same way, pi 4 can be added in a constructive and destructive way, so we will get this orbital. So in this way, the octatetraene, the pi molecular diagram of octatetraene can be understood. Now, in my next lecture, you will see the construction of pi molecular orbital diagram for allylic system or odd carbon systems. Okay, thank you.